Hello and welcome to Easy Projects. So in this video we're going to be making a lithium-ion battery pack. So I've been playing around with an AR drone 2.0, but I find that the battery runs out way too quick. This is a 1000 milliamp hour free cell battery, and it gives about 7 minutes of flight time, which is not very much. So you can actually just buy larger battery packs. One of them is 1500 milliamp hours and another one is 2200 as far as I remember. But I read on the internet that if you buy the 2200 milliamp hour, it's a lot heavier, and it actually causes the drone to be unstable, which is not a good thing. And the big battery is about 170 grams, I think it is. The 1500 milliamp hours is 115 grams, and this one I weighed at 104 grams. So I had a look around at Hobby King, and I found these very cheap Lipo batteries at 900 milliamp hours each. And 6 of these weighs in at 102 grams, so a little bit less than this one. But that's without the wires and the connectors. So I'm pretty sure even when these are soldered up, they will weigh less than the 1500 milliamp hour battery, but this will give me 1800 milliamp hours. I probably should note that I could buy a finished pack cheaper than I could get these batteries, but there weren't any that would fit in this form factor, so when I stack these up, they will actually be a little bit less than the original. You see something like this, a little bit shorter, the same height except for 2 millimeters, and approximately the same width. So the batteries are going to be put together 2 and 2 in parallel, and then 3 sets in series. You have to be a little bit careful when you wire batteries up in parallel like this. If the voltage on the batteries are not exactly the same, then you'll have a very big rush of current from one battery to the other, and that can damage the battery, or in the worst case set stuff on fire, and we don't want that. So we're going to take a look at how we make sure that doesn't happen. If you're going to wire them up in series, then it's not really a problem. You still need to be careful, but the voltage of the batteries doesn't really matter. So first I'll just measure all the batteries to make sure that they're good. So 3.93 volts, 3.94, 3.93, 3.93, 3.945, and 3.95. So as I mentioned, now that I'm going to wire these two batteries up in parallel, if they don't have the exact same voltage, once you connect both ends together, if this is charged more than this battery, we'll have a lot of current going from this battery to this battery. The greater the voltage difference is, the more current we will have. But since the internal resistance in the batteries are very, very low, even a small difference in voltage will result in a huge amount of current, and that can damage the batteries. So before we can solder them together, we first have to equal out the voltage. And you can do this in many different ways, but the easiest way is to just connect a resistor across them. So the negatives you can just hook together with a pair of alligator clips. And then I'm going to use a 0.47 ohm resistor. These batteries are very close, they are basically new out of the box, but if yours aren't that close, you may want to start with a higher value so you don't get as much current flowing. So I'm going to hook up a multimeter here so we can see how much current is flowing from one battery to the other. So in this case it's basically nothing, 12 milliamps. But there's also a lot of resistance in all these wires, so I think we can actually do without the resistor. So in that case it wasn't very bad, you could probably just have soldered those together. But I've taken another battery here, also straight out of the box, and if we hook that up, you can see we have about half an amp going through the cables here. But to sum up, you just need to make sure that the cell voltage is about equal between the two cells. So I went and did this for all the pairs that I'm going to solder together, and none of them were critically high actually, so I probably didn't have to do this. But if you get some batteries that are slightly out of balance, like the other one that I showed you, where it's about half an amp, you can just leave it and it will settle out to about 10 milliamps or something, then it should be good enough. But again, if your difference is in the hundreds of millivolts, then start out with a half ohm power resistor or something first, just to make sure that you don't burn your cables or damage the batteries. So I'm going to somewhat line up the tabs of the pairs here. The batteries are probably not made perfectly, at least these aren't, and then I'll give them some Kapton tape to hold it together. So, like that, and then we're going to put them like this, so that we make sure to go from positive to negative, positive, negative, positive, negative. So before we solder the wires, we go ahead and tin all the connections first. It's a good idea to use some flux on the tabs here, so make sure you get a very good connection. So you're going to want your positive from the end where you have two positives, of course. And you should be using fairly thick wire, at least enough to carry the current that you want out of the pack. So I'll just wrap a piece of electrical tape around it so it doesn't short out to anything. So when you solder this negative pair to this positive pair, you have to be careful that you don't heat the wire so much that it unsolders itself over here. So you need to be fairly quick. So I went and did the other side the exact same way. Black to negative, and then just connected the other four. The only difference is on this side you have to be extremely careful that you don't touch these together, because now they're connected on the other side and you would create a short circuit then. Just be extremely careful when doing the second side. So all we need left is the balance connector and the actual power connector. The 4-pin connectors were out of stock on Hobby King, so I had to get the 5-pin ones. And I moved the red from this hole to this hole. They can still be used, but of course I would prefer to get the 4-pin ones. Normally they are color-coded like this, where the black is the negative, of course, and the red is the most positive. We just still have to do the same thing here. So this black should be the negative, and this red should be the positive. And the second black here should be the first cell, and the last black should be the second cell. For the balance connector, it can be a little difficult to solder it onto the existing connections here without desoldering the wire. What you can do is to twist them onto the wires before you solder them on. Or you can remove a bit of the insulation here and solder it to that point. Also, for the positive and negative, you can remove the insulation here and solder it here. And once we're done, we will tape this firmly down to the pack and cover it with a heat shrink and tape. So it shouldn't be a problem. So I just remove a bit of insulation from the wire and tin it. And then you get a good connection like that. So this is all the connections wired up, except for the main power connector. And before we proceed to do anything, I just want to check that I got my wires correct. So this should be 1 cell, 3.9 volts. This should be 2 cells, 8 volts. And this should be 3 cells, 12 volts. So I got my wires correct. And now we can go and cover up all the bare connections here. And tape the connectors and wires in place so that we don't rip them off the joints. So I think to begin with, to keep everything where I want it, I want to run some Kapton tape along the top and the bottom. And I want to cover up the ends a little bit better here, so if it gets a shock or someone drops it, it doesn't hit directly on the connections. So I went and cut a piece of cardboard for that. And I'm just going to mark the ends like that. And I just cut it so that we can fold it around. It wasn't perfect, but something like this. But I just want to cover this up first with some tape. So for the main power connector here, we want to do one at a time and keep the other one far away. I also try to keep the balance connector away. So I didn't quite get enough tin on there. So that's better. And we want to shrink the heat shrink. And then we should be safe to do the other one. So I'm trying to add a little bit more solder this time. And perhaps I should remember to put the heat shrink on. Yes, that looks fine. We're going to shrink it. And let's just, for good measure, check with the multimeter that we got the wires in correctly. And it looks like a positive voltage to me. So now that this is finally assembled, we can weigh it on a scale and see if my estimate was correct. This is the original battery. It weighs in at 104 grams. The 1500 milliamp hour battery that I could buy would weigh 115 grams. So let's check this one. It's 118. So 3 more grams for another 300 milliamp hours. So this is 14 grams more than this, and I bet you that we won't notice the difference, except in the flight time. This should fly almost twice as long. Also, I could probably cut down on the weight a little bit if I removed the cardboard and used a little bit less tape, and then shortened these wires on the balance connector, and also these, got these to a minimum. Then we could probably shave off another 4 or 5 grams, but I don't think it's really worth it. I don't think I'm going to notice anyway, so there you have it. It's not pretty in any way, but it should be pretty safe. At least comparable to one of the standard ones that you buy. Just keep in mind not to use more power than your cables are rated for. Now I just need to charge it up and test it. So let's do that. Oh, and actually for it to fit in the charger I need to remove this clip here. It has to be like this. So I went out and tested it, as you saw, and the results are pretty good actually. Now for each test I crashed the drone once, so I count that as an equal amount of downtime, and I recorded for a total of 8 minutes with the first battery and 15.5 minutes with my homemade battery. So it's almost double the amount of flight time. In both cases I took the battery down to 15% on the battery monitor on the phone, and the batteries are drained down to 3.7 volts under no load, which is pretty safe. It has probably been down to 3.4 something under load. One thing to mention though is the original battery gets a little bit warm, but once you're up in double the capacity it gets hot, probably 60 or 65 degrees Celsius. It's not really that uncommon. In many applications lithium polymer batteries get up to 60 degrees when they're discharged very fast like this. One thing to note though is as the battery ages, the internal resistance increases, so you need to keep an eye on it so it doesn't run away one day and melt down your quadcopter or your RC car, whatever you're using it for. All in all, this solution seemed to work out pretty well. The 14 grams extra didn't have any noticeable impact on the drone. It was a bit windy out there, not very much, but the AR drone doesn't seem to like any kind of wind. You saw I crashed it a few times. So I think the next time I'm going to play around with it, there should be no wind at all. I would kind of have liked to take it a little bit further up so we could see above the trees in the forest, but I didn't dare to do that. It felt like I could lose control of it any second, and I did a few times, so that will have to wait for another day. Anyway, thanks for watching this video, and if you liked it, please give it the thumbs up, and I will catch you soon for the next video. See ya!